Okay, so I'm going to go through the solutions of these. First, we're going to complete the sample space. So very similar to what we had before. So now we've got a coin and we've got a spinner. So our possibilities are 1 in heads. I can have 1 in tails. 2 in heads, 2 in tails. 3 in heads, 3 in tails. 4 in heads, 4 in tails. So the probability of getting a heads and a 4, we can look there. It's just going to be where there's only one of them out of a total of 8 possibilities. The second question says, what's the probability of getting a square number and a tail? So square numbers, we've got 1. 1 times 1 is 1. So 1 squared is 1. And 2 times 2 equals 2 squared equals 4. So our square numbers with tails, we've got 4 on the tails and 1 on the tails. So we've got 2 out of 8. We could also write that as a quarter. Next question says, what's the probability of getting a heads and a 1 or a tails and a 2? So heads and a 1 is here. Tails and a 2 is here. So now we've got or. We're just going to add these two together, the two probabilities. So we've got a 1 out of 8 plus 1 out of 8. If we add those two together, it's going to get 2 out of 8. And again, we can simplify that to a quarter. So again, this is showing how we get to this AND rule. So going forward, we're not going to think too much about listing. We're just going to, if it's an AND, multiply. And we can do that for these two questions. So if we said, a fair 6-sided dice is rolled twice, what is the chance of rolling 2 6s? So that'd be a 6 and then a 6. So for the first 6, it's just going to be 6th. And the second one, again, it's going to be a 6th, and because it's and, we're going to multiply the two together. So it's going to be 1 out of 36. So if you think of a coin is flipped twice, what's probably getting 2 heads? So that's a head and then a head. First one, probability is a half, multiplied by probability of the second thing. So we're just going to end up with a quarter. And if we look at the sample space for these two, it shows where this comes from. So we said a head and a head, that's just 1 out of 4 possibilities. And then we said a 6 and a 6, so that's 1 out of here, 36 possibilities. Okay, so the reason we've gone through all of this is because we're going to look at tree diagrams. So there's 2 different cases for tree diagrams. One we call independent, and that is where the events that happen do not affect each other. So the first event does not affect the probability of the second event. So often when we see these in the questions, it's going to be when items are replaced. So this example, I've got 3 red and 2 yellow counters in the bag, which you can see here. And I'm going to pick 2 at random. So I'm going to do 1 and then the other. When I pick a counter, I replace it. So as soon as I take one out, I'm going to make note of the probability. I'm going to make note of what I get. I'm going to write down the probability of my tree, and then I'm just going to put it back in. So just to illustrate this, first thing says for my first pick, what is the probability that I get a red counter? So I can just look at my bag, and I've got 3 out of a total of 5. So I'm going to write 3 out of 5. What I'm actually doing there is I'm reaching into my bag, I'm taking out a red counter, and then I'm noting that I've got the red counter and I'm moving on. I've just written down the probability there. Because I'm replacing it, for my next pick, it's going back into the bag. So in fact, what this means is for my second pick, the probabilities do not change. So I can say for my second pick, what's the probability of getting a red counter? That's still the same. Still going to be 3 out of 5. And the yellow, just 2 out of 5. For my yellow here, it was my first pick. I'm still looking at the same bag, so I'm just going to have 2 out of 5. And then red pick for my second pick, because I put it back in. 3 out of 5. And 2 out of 5. The other thing I can do with these is I can say, what is the probability, for instance, of getting a red and then a red? So if I'm going to start that here, that would be getting a red and then a red. So remember, this is and, red and then a red. So I'm going to multiply. So I'm just going to do a few of these, and on the next slide, I've got all of the solutions up. For here, I would just do 3/5 multiplied by 3/5. So 3 times 3 is 9. And on the bottom, I'm going to have 25. So that would be for the red. My next slide, I've illustrated all of these just to save a bit of time. The other point that I do want to make is that for each of the picks, so for the total events that can happen, my probabilities are going to add up to 1. So for these two branches, my 3/5 and my 2/5 are going to add up to 1. Here, my second pick with 2/5 and the 3/5 are going to add up to 1 again. So I'll illustrate this on my next slide. So here I've just got all of the probabilities written down. This is exactly the same question as before, except I have also got the probabilities of getting a red and a red, red and a yellow, yellow and a red, and a yellow and a yellow. The final check I can do is say all of these probabilities should also add up to 1. So 9/25 plus 6/25 plus 6/25 plus 4/25 needs to add up to 1. If it doesn't add up to 1, I've made a mistake somewhere. I can go back and I can double check. When you see these in the exam, they often come as questions where, first of all, you fill in the tree diagram, so you complete it, and then they're going to ask you some questions about it. So I've got 3 questions here. One of them says, what's the probability that I pick a red counter and then another red counter? So I can just follow my branches here. I pick one red, and then I pick another red. So red and red, I would multiply the probabilities. 3 divided by 5, so 3/5 times 3/5 is 9/25. So let's write 9/25. My second one's a bit more tricky. So it says, what's the probability of getting at least one red counter? So if I get a red and a red, I get at least 1. If I get a red and a yellow, I get at least 1. If I get a yellow and a red, I get at least 1. So if I get a red and a red, or a red and a yellow, or a yellow and a red, I get at least 1. I need to remember that for or, I'm going to add my probabilities together. So here, I'm going to need to do red and a red, 9/25, plus red and a yellow, 6/25, plus a yellow and a red, another 6/25, and I can say 9 plus 6 is 15, plus another 6 is 21 out of 25. Another question I could ask you is, what's the probability of getting one counter of each color? So if for me to get one counter of each color, that would be either red and yellow and red. So again, it's this one or this one. I'm just going to add the probabilities. So 6 out of 25 plus 6 out of 25, which is going to give me 12 out of 25.